Assalamualaikum warahmatullahi wabarakatuh. Good day everyone. My name is Fatimah Naya Ramadhanti and I'm from Group 8, and today we're going to present our final project where we analyze UI's Wi-Fi in the second floor of iCELL building FTUI. First, here I'm going to walk you through the step-by-step just simply on how to use the Netspot. First step, of course, you have to download and install the Netspot. You can visit the official Netspot website and download the appropriate version for your operating system, whether it's Windows or Mac OS, and then launch Netspot. Simply here, you just click on the survey and start survey, and then you have to import your map or blueprint of the area that you want to survey. And then you click on start survey and begin analyzing the Wi-Fi signal strength in the selected area, where you basically just walk around the area with your device, with your laptop, and Netspot will collect data points on the Wi-Fi signal strength. This is the example on how you should walk around with your device to collect data for your Wi-Fi. And this is how your screen would look like. So that's basically it, and now we're going to explain the result that we got. So first, here is the general info. Our project take place in iCELL building on the second floor, and the surveyor is Ahmad, Reyhan, Palakka, my partner, and of course myself, Fatimah Naya Ramadhanti. And our survey started on December 6, 2023 at 2:55 p.m. and ended in the same day at 3:27 p.m., where it means our survey total duration is 41 minutes. Okay, for the first result, here is the signal level. The areas marked with number closer to -45 to -60 dBm shown in green have a very strong signal strength. As the numbers increase or get more negative, the signal strength decreases. For instance, areas marked with values like -65 to -70 dBm are likely to have moderate signal strength. And we can see on the map here that it's all covered in green, which means the area basically have a very strong signal strength. And then it's signal to interference ratio. These are areas where the signal is stronger than the interference. Values closer to 0 dB might still experience some interference, but as the number increases, the signal becomes more dominant over the interference, which is ideal for good communication quality. But here on the map, I see two sampling points that has 0 on the pin. I think that's faulty from the Netspot, because in the map, even though it's 0, it's still green. So I think that's one mistake. And then we have quantity of access points. Yellow to green areas indicate moderate coverage where the signal is acceptable but not as strong as the red areas. There might be fewer APs, or they might be spaced further apart. Blue areas could be unserved by the current AP setup, indicating either a signal AP with limited reach or a lack of AP coverage overlap. If these areas require service, additional APS might be needed. Next, we have frequency band coverage. These areas in yellow are likely to have better coverage but may suffer from interference, especially if there are many other devices in the area that uses the 2.4 GHz band. The orange areas offer flexibility for devices to switch between the two frequency bands depending on the requirements. Users in the same areas can benefit from both good range and speed. As we can see on the map here, it's mostly dominated by the yellow, which is the 5 GHz, which is good, but we can still see some orange here and luckily no red, so that means we're good. And then we have the PHY mode coverage. The areas covered in purple suggest where certain PHY modes are available. In this case, it means that the Wi-Fi works at 5 GHz with maximum data rate of 54 Mbps. And next, my partner Palakka will continue the explanation.
So for the download speed, since the heat map is predominantly blue, this suggests that the download speed across the area are on the lower end of the scale provided, the scale being 0 to 10. This could indicate an issue with the network capacity, signal strength, or network configuration, or maybe a fault in the application. For the upload speed, is similar to the download speed. The blue color across the heat map suggests that the upload speeds are consistently low throughout the building, potentially at or near 0 megabytes per second, which is indicated as the low end of the scale. This might indicate a significant issue with the network's upload capabilities, or again, a mistake in the data collection. For the wireless transmit rate, given the scale goes from 0 megabytes per second to 500 megabytes per second, the blue color across the map suggests that the transmit rates are very low throughout the coverage area. The low signal level, the areas of red on the heat map indicate zones where Wi-Fi connectivity is likely to be problematic, which with slow speeds, high latency, or disconnections. The yellow areas are better, but connectivity issues may still exist, especially for demanding tasks like video streaming or large file transfers. The overlapping channels, or SIR, predominantly red areas indicate a high level of interference compared to the actual Wi-Fi signal. This could be due to overlapping channels where multiple access points, or APs, are operating on the same or adjacent Wi-Fi channels, causing interference with each other. High interference will lead to poor Wi-Fi performance as devices struggle to communicate effectively. Conclusion. So the consistent presence of red zones across the different heat maps indicates significant areas within the building where the Wi-Fi network is underperforming or non-functional. This suggests a systemic issue that could be due to a combination of factors such as improper AP placement, channel interference, outdated equipment, hardware malfunctions, and possibly inadequate network design or configuration.